In this video, I'm doing an example of finding minimum average cost. So take a moment and read the example. So the first thing that I want to make sure everyone notices is that our function, the cost function here, is not the average cost function. It is the cost function. We need to then find the average cost function from the cost function. The second thing everyone should realize is that there is only one independent variable, and that independent variable is the Q. So there are not two independent variables, only one. So therefore, we do not need a constraint equation. And that once we find the average cost function, that will be our objective function. So the average cost function, we simply take our cost function and we divide it by Q, the independent variable. That will give us the average cost. And so that function is going to look like this: 0.08Q plus 3 plus 20Q to the negative 1. So that is the average cost function. Now, in order to find the minimum average cost, this is when we need to use some calculus. So we're going to find the derivative of this. And finding the derivative, C bar prime of Q, we'll have 0.08. The derivative of 3 is 0. And then this will become minus 20 Q to the negative 2. So that is the derivative. And to find the minimum average cost, we need to set the derivative equal to 0. And then solve this for Q. So to solve it for Q, we will have 0.08 equals 20 over Q squared. So I'm simply taking this and moving it over to the other side. And I'm also putting the Q to the negative 2 down in the denominator. Cross multiplying and solving for Q squared, we have Q squared equals 20 divided by 0.08. 20 divided by 0.08 is 250. That's Q squared. So Q is equal to the square root of that. And that is going to be approximately 15.8, which we cannot have a fraction of a beach ball. So we will round that up to the nearest integer, which would be 16. So selling 16 beach balls should give us some optimum solution, preferably the minimum average cost. Now, the last thing that we need to do is to determine if this truly is a minimum and not a maximum. Okay, we're looking for the minimum average cost. And so remember that when we take a function, we find its derivative and set it equal to 0, we are finding critical values. And so the critical values, or extrema, are either relative max or relative mins. We don't know if this is a max or a min until we use the second derivative test. So I'm now going to use the second derivative test to determine if it is a relative max or relative min. So that means we need to find the second derivative. So C bar double prime of Q is going to end up being equal to 40 over Q cubed. All right, so we're taking, here's my first derivative. And so taking the derivative 0.08 is 0. And so we're taking the derivative of this to get 40 Q to the negative 3, or 40 over Q cubed. Now what we want to do is we want to evaluate this at 16. So we're going to put 16 in here. And so we get 40 over 16 cubed. Now, I'm not going to whip out my calculator because I don't care what that number is. Remember, when we're using the second derivative test, all we're concerned about is my answer positive or negative? Is this going to be a positive value or a negative value? Well, clearly there's no negative anywhere in sight. So this is going to be a positive value, which means that at this particular point, the curve is concave up, which means we have a minimum. So this gives me a relative minimum. And so that is what we are looking for. We have now verified that 16 is a relative minimum, and 16 is the quantity that will give us the minimum average cost. Now, to actually find the minimum average cost, you would simply go back to the average cost function, and you would evaluate the average cost function at Q equals 16. So our average cost function is right here. Either one of these versions you could use. Don't accidentally use the derivative. We want the average cost function now, okay, evaluated at 16. And when you plug 16 in for Q here, that would give you your average cost at 16, a quantity of 16 beach balls, which will be your minimum average cost.